Welcome back to Joint Conditional and the Two Laws That Run Everything, Part 3 of 8. In Part 2, we conditioned the return on the regime. Now, two ideas. First, conditioning runs both directions, and the reverse direction is Bayes' rule in table form. Second, independence, the case where conditioning teaches you nothing, which hides a famous trap that confuses uncorrelated with independent. We condition return on regime because that matched Sam's decision, see the regime, forecast the return, but the same table answers the reverse. Suppose Sam sees a bad day, x equals minus 2%, and asks how likely is it the market was actually stormy. That is the probability of y equals 2 given x equals minus 2%. Conditioning regime on return, reading up a column instead of across a row, dividing by the column total. The probability of minus 2% is 0.20, so the answer is 0.15 over 0.20, which is 0.75. 3/4 of Sam's minus 2% days are stormy, even though stormy days are only 30% overall. Conditioning on the bad return updated Sam's belief from 30% up to 75. That flip is exactly Bayes' rule in table form. One caution: the definition divides by the marginal of y, so it is silent when that marginal is 0. You cannot condition on an event that never happens. For discrete y, this is a harmless edge case. But for continuous y, every single value has probability 0, so the naive ratio is 0 over 0, and the definition has to be rebuilt with densities. We use the discrete picture all chapter because the arithmetic stays visible. The intuition, look at the slice of the world where y equals y, then average over it, stays exactly right. Independence is the special case where the conditioning move is a no-op. If learning the regime tells you nothing about the return, then x and y are independent. Formally, they are independent if the joint factors into the product of the marginals for every pair of values. Equivalently, the conditional equals the marginal, so conditioning teaches you nothing. Are Sam's x and y independent? Test the easiest cell. If they were, the COM plus 2% cell would equal the marginal of plus 2% times the marginal of COM, 0.35 times 0.70, which is 0.245. The actual joint is 0.30. One failing cell is enough. Regime and return are dependent. That is the whole point of Sam's strategy. If returns were independent of the regime, there would be nothing for a regime-aware trader to exploit. Here is the subtle trap. Independence is strictly stronger than uncorrelated. Two variables can have zero covariance yet still be dependent because covariance only detects linear association. Picture a variable y equally likely to be minus 1, 0, or plus 1, and set x equal to y squared. Knowing y pins down x exactly, yet a quick calculation gives covariance of x and y equal to 0 because the relationship is symmetric and bends rather than slopes. So uncorrelated never licenses you to assume independent. Conflating the two is one of the most common analytical errors in applied work. To summarize Part 3, a single joint distribution answers a question in its converse. Regime given return is Bayes' rule in table form, updating Sam's belief from 30% to 75. Independence is the case where conditioning teaches nothing. The joint factors into marginals, and Sam's table fails that test. Crucially, independence is strictly stronger than uncorrelated. Zero covariance never licenses independence. In Part 4, we build conditional expectation, the single most useful object in the course.